India's agricultural sector spans millions of acres, acting as the economic engine of the nation. From above, it looks serene, almost effortless. But down in the dirt, that illusion shatters. For generations, preparing the soil has demanded severe physical endurance. Farmers and their oxen must drag heavy wooden plows through hardened, uneven earth just to start a single season. Protecting the crop is even more hazardous. Workers strap heavy liquid tanks to their backs and navigate uneven terrain for hours in extreme heat, completely enveloped in chaotic, drifting clouds of toxic pesticide. And despite that grueling labor, diseases and pests still win. A localized blight can destroy an entire harvest, leaving a farmer standing isolated in a dying field, completely out of options. Addressing a challenge of this scale, over 100 million farming households, requires a shift in the underlying infrastructure of the village itself. Physical endurance alone cannot compete with these levels of environmental and economic risk. Handing a farmer a slightly better tractor or a standalone smartphone app only treats the symptoms. It does nothing to solve the core unpredictability of the harvest. These communities suffer from severe infrastructure isolation. The highest levels of deep tech, artificial intelligence, automated robotics, and real-time data grids are built for urban centers. They completely bypass rural agrarian villages. Closing that gap means bypassing traditional development steps. It means dropping an entirely self-contained, aerospace-grade digital ecosystem directly into the rural dirt. This is the Meghdev drone station. Constructed from repurposed shipping containers and powered by advanced solar arrays, this modular digital airport sits completely off-grid, operating right in the middle of local farmlands, and it is managed locally. Meet the Hal Didi, a woman from the community who has transitioned out of manual field labor to become a certified technology entrepreneur running this command hub. The entire massive system activates through pure simplicity. A farmer requests a crop spray via a standard WhatsApp message. The Hal Didi receives the request on her tablet and processes the order through the station's internal HAL ERP system. The moment she hits approve, the station wakes up. Robotic arms inside the charging docks load a fresh battery, prepping the Vigo drone for flight. This single interaction turns the village from a site of manual struggle into a data-driven command center. Advanced aerospace tech is now a daily utility, placed directly in the hands of the people who live there. Before a single rotor is allowed to spin, the system initiates a strict no permission, no takeoff protocol. The software pings the National Digital Airspace Grid, securing encrypted clearance to ensure the flight path is safe. As the white drone lifts off, it maps the farmland into what engineers call a digital twin. This translates the physical soil, crops, and terrain into a measurable, tokenized digital asset. The digital twin framework starts with the 1 square meter tile, used to plan broad operations like irrigation. Inside is the 1 square centimeter cube, guiding targeted crop spraying. Finally, the 1 square millimeter pixel allows AI to scan individual leaves, diagnosing ultra-local diseases early. This centimeter-level digital architecture replaces generations of anecdotal guesswork with a high-fidelity map of the farm's actual needs. Predictability is finally becoming a feature of rural life. Out over the canopy, the drone navigates autonomously using RTK positioning, tracking its location down to the centimeter. It applies a perfectly uniform chemical spray, slashing pesticide waste by 40% and completing hours of brutal work in minutes. The data gathered during this flight feeds directly to the farmer's smartphone. Instead of waiting months to see if a crop survives the season, he receives a yield estimate based on real-time plant health. The mission concludes as the drone autonomously returns to its dock for battery swapping and chemical payload loading. Throughout the entire process, no human hands ever touch the hazardous materials. The result is a dual human victory. The farmer secures his family's livelihood through hard data, while the Hal Didi achieves economic independence and respect as a high-tech leader in her community. But this single village Hal center we just witnessed is merely the last-mile node in a staggering national architecture. The logistics network scales upward. Local village nodes connect to larger block-level Vigo centers. These regional hubs manage the electric vehicle fleets that keep drones, spare parts, and expert technicians moving across the terrain. Those block centers then feed into the ultimate tier, the district Meghdev stations. This forms an interconnected command grid specifically engineered to cover all 831 districts of India. Once these rural drone airports are active, their utility expands rapidly. This exact same infrastructure unlocks emergency medical deliveries, industrial logistics, and coordinated national disaster response. By anchoring aerospace technology in rural soil, Ojas Aerospace is engineering a digital nervous system for the nation, building progress from the ground up.